Hi, now we'll talk about column transformer and the text featureizations, right? So again, here we are importing few stuffs, right? So here we have imported the simple imputers, we have imported the cross validations, here we have imported the pipeline and the models and the plotting tools, right? Now in this lecture, we'll talk about how to use column transformer, right? What are the different steps that needs to be done in that needs to be there in to make a column transformer, right? We'll see how to do the one-hot encoder. We'll see how to appropriately encode one-hot encoding and ordinal encoding, right? We'll see how to deal with the categorical variable with the too many categories, how to deal with the text data, what is count vectorizer, what are the different parameters of the count vectorizer, and we'll see some text like we'll incorporate the text features in the machine learning pipelines, right? Now here, so in most applications, some of the features are categorical, some are continuous, some are binary, and some are ordinals, right? So in let's say that if you have a data set, right, that data set can have the mix of the data types, right? And when we want to develop a supervised machine learning pipeline on the real world data set, right, we often need to apply a different type of transformation on the different type of data or on the different type of columns or features, right? For that, we can use the column transformer. Now, to understand the column transformer, let's look at the toy examples. Here we have this toy example. Now, this is all these are the numerical value. This is the numerical value with the nan value, right? This is the ordinal value. This is the so again, so like not ordinal, but this is categorical. Now we have this class attendance, which is the ordinal data. This is our categorical data. This is our binary data. This is also our binary data, right? So here we'll do different type of transformation on different type of data, right? And to showcase, we'll use these data set, right? Here we can check the basics info of the data. Here you can see that lab 2 has the two data missing, right? So we have the two nan value in the lab 2. One is here, another one is here, right? Now we can check here we are just trying to print the first example of the data, right? Now how do we do that? So by looking at the data, we know that we have to do the scaling on the numerical features, one-hot encoding on the categorical features, and the binary features we have, which is the enjoy courses. Here also we have to do the one-hot encoding. We can apply the ordinal encoding on the class attendance. This is our ordinal data, right? Imputation we have to do in the lab 2. For ML experience, there is already, so basically this ML experience is already data converted, right? So we have this one and the zero, so we do not need to do, right, any process on the ML experience, right? So now we know how to do like which feature require which type of features transformation, right? Now again here we are separating our x and the y part of the data. Now again, let's first check the first five element of the x data. Now here, what we're trying to do is, here we are separating a different type of numerical features. So we have separated the numerical features, we have separated the categorical one, the pass-through feature, which is the ML experience. This means that we do not want to apply any type of transformation on this. Here, for now, we are dropping lab 2 class attendance, right, and enjoy courses. For now, we are dropping these columns, right? So we'll kind of apply on these columns transformations, right? So for simplicity, let's focus on the scaling and one-hot encoding now, right? Here to create a column transformer, this is similar to the pipeline. We need to import the column transformer, right? And again, just like a pipeline, here we are creating the column transformer object by passing a different type of transformation on the different features, right? And here as well, we have to give a name for the different type of object. But instead of that, we can use of the make column transformer, right? Which, like if you're using the make column transformer, this means that you do not need to use any type of like naming convention for every object, right? So this syntax automatically name each step based on its classes, right? So here to kind of import the column transformer, right? Here we have imported from the compose. Here also we'll import from the compose. We are importing make column transformer and then we are using this make column transformer. Now here we just need to pass what type of transformation and on what features. When we say pass through, this means that we do not want to apply any transformations. And here we want to apply pass through on the pass through feature. That means we do not need to do any type of transformation on this. Why not encode on the categorical data, drop on the drop features, right? We have these drop features, right? Now we can check our column transformer. So here we'll see the kind of steps for each features, right? Like each type of transformation we can see over here, right? Now to do the transformation, we just need to apply fit and transform method, right? So here we are calling city.fit and transform. We are passing on the x data, right? And which returns you the transformed data. Basically, this will be a 2D matrix, right? This will return you the 2D matrix, right? And here we can check that the data type will be the ND array from the NumPy, right? Here is how our data, transformed data looks like, right? Now, viewing the transformed data as a data frame, basically to do that, what we need to do, we can view our transformed data as data frame. So by adding columns, right? So basically here our original columns is for the numerical features will not change, right? But for the categorical feature, the number of columns will be changed because on the categorical feature, when you do the one-hot encoding, we know that one-hot encoding will kind of increase the number of columns as the number of category we have, right? So if we have a column with the 3 category, so from one column it will be now 3 columns, right? So for every category there will be a new columns, right? So here we need to create a column name for those features. So how do we do that? Here we are adding the numerical features. Again, we have to give the same way as we have given into the transformation. Like first we need to pass the numerical, then the pass through, and after that categorical feature. So here we are adding, and in this sequence only our data will transform, right? So here we are first adding our this numeric feature, then the pass through, and to get all the columns, all the transformed columns from the transformer, right? So basically we can use this technique, right? So from this like from this one-hot encoder transformer, we can use this get feature names out. This will give you all the feature names, all the transformed feature names, right? And here we can check that. Here we can see that. So our transformation has been done on the major column. Now, so here we are getting major biology, major computer science, major economics, major linguistic. So for every category, we have created a new features, and we have kind of created a new columns names, right? And now we can simply pass the data and the column names, and that will be our data frame, right? So here we have these columns, and earlier we had a kind of quiz one, we have the ML experience. Now we can see all our columns, right? Here we can see all our transformed column. So generally, if we have the categorical data, right? So only the categorical features will be expanded, right? Not the numerical features will be expanded over here, right? So we need to make sure to kind of combine the feature names, combine the column names for that, right? And here is how the pictorial information of how the transformation happens. Consider that this is the blue one as the numerical one, this is the categorical, and this is the other one. So now here on the numerical features, what we have done, we have done the scaling, right? And the number of feature has not increased. On the red one, which is the categorical one, we have applied one-hot encoding, and after one-hot encoding, we can see that the number of feature has been increased, but for pass-through, there is no transformations, right? So we have to add in at this format. So here we'll add numerical, categorical, and then the others. right? So here we can see that when we apply the 100 encoding, right, the number of columns will be increased over here, right? Now, after you get this, right, now what we can do, so basically, this is our transformer, right? Now we can see that the data from the transformer, but we can directly pass this transformer and combine with the SVC using pipeline. So here we are combining our this column transformer with the machine learning model using pipeline, and now our model looks like a pipeline. Now we can apply fit and transform or like fit and predict on the pipeline method, and it will give you the output. Here we can see how the pipeline looks like, right? Now this is how, so we have done the transformation on our toy data set, right? So now we'll learn some more feature about transformations. Now we'll do some more transformations on the features, right? Again, if you want to see this transformation like a diagrams, right, you can import this set config, and then you can use this set config functions to kind of display this column transformer as a diagram. Again, if you run this, you will see how this diagram, like how this column transformer looks like, right? Now, again, earlier we have dropped our lab2 features because it has nan value. Here we can see that, right? So what we can do, we can so the question is, this lab2 needs to be an imputation and scaling both type of transformation. So we can treat lab2 separately, but we can include lab2 into the numeric feature, and then for all numeric feature we can do the imputation and the scaling. So if there is a requirement for the imputation, it will done the it will do the imputation, and then after it will do the scaling, right? So here we are including lab2 in the numeric feature. In the categorical we have the major, for the pass through we have the ML experience, and the drop feature we have the true class attendance and the enjoy process. Again, the same column transformer we are using, but this time here we want to do standard scalar and simple imputer, two type of transformation on the numeric feature. Now we need to combine these both transformations. So to combine this, we can use the pipeline, right? So here we are using make pipeline, right, to combine both transformation, and then we are applying and then we are passing on which feature we want to apply this transformation, and everything is same after that. Again, after this, we just need to call fit and transform on the X data, and then we can see the data over here. So here we are seeing all the columns, right? And after that, we can simply see our transform data. So now we have the lab2 in this, and lab2 has been replaced with the nan value. Now we can see that there is no nan value is available in the lab2 features, right? Now, class attendance was the ordinal features, which is different than the major column, right? So ordinal means, so here we have this ordinality of the excellent, good, average, poor, and again, we have as a human being, so right, as a user, right, we have to understand that which which value has the highest order and which value has the lowest order, and what is the order, exact order we have, right? So here as a human being, we know that excellent has the highest rating, then the good, then the average, then the poor, right? So now we have to order, we have to do this, like we have to apply the same ordering on this class attendance features, right? So here for that, how do we do that? So here to kind of focus this, here we have just selected the class attendance. We have created the object for the ordinal feature. We are applying the fit method and then the transform method. After the transformation, here we are saying all the like both our original data and the transform data. Here we can see that excellent has the value as 1, average has the value of 0, poor has the value of 3, and the good has the value of 2. Now this value has been given is not appropriate, we can see that, right? This code does not always understand what should be the order, right? As a human being, we have to give the order. So it has automatically detected based on the given the order based on the alphabetical order, right? So the average A comes first. So it has given the 0 as a value. Then the E comes For the excellent, then it has given the 1 as a value. Then the G comes, then the P comes, right? So it has given there like it has given the value based on the alphabetical order, but in reality it is not, right? So how do we do that? So first we can take the unique value, right? And here we have to create another variable. So here we have created another list by depicting the actual label from low to high, or you can also pass from high to low. So we are saying that the poor comes first, then the average, then the good, then the excellent, right? So the number will be assigned to the poor will be 0. The number will be assigned to the average will be 1. The number will be assigned to for the good it will be 2. For excellent it will be 3. Right? So now we can pass this list, right? When we will do the ordinal encoding, right? So here in the ordinal encoder, when we want to create the object of the ordinal encoder, right? Here we are passing the categories as an, so here we are passing this list inside another list, and this is how we have to do, right? So we are saying this categories equal to, and then we are passing this class attendance label, this entire list. And here we're saying the d type as an integer, that means it will do the encoding. So by default it is a float, but it will do as an integer, right? And after that, when we do the transformation, now we can see that the average, so the poor has been labeled 0, average has been labeled 1, good has been labeled 2, and the excellent has been labeled 3. Now it looks kind of meaningful, right? And it is not a float value, it is an integer value, right? So now our encoded category looks better, right? Now, if you have more than one ordinal column, right? So we can pass the manual ordered category when we create the ordinal encoder object as a list of list, right? So here we can pass that this is the first list, right? We can pass the comma. After the comma we can pass another list, right? For the another ordinal category, right? If you have more than one ordinal columns, manually create a list of ordered category for each columns, right? So manually we have to create the ordered categories and pass the list of list to the ordinal encoder, where each inner list corresponding to the manually created list of the ordered category for the corresponding orders, right? Now here we are incorporating ordinal encoder of the class attendance to our column transformers. So now this is our x now. This is our x now. Now our transformations will be, so now in the ordinal feature, we are passing the class attendance as an ordinal feature. ML experience is a pass through, and now we are only dropping one features, right? So now we have added our ordinal features. Now we are creating again a column transformer. So for this numerical, we have created a pipeline. For the ordinal, here we can see that we have passed the class attendance level, then the pass through, then the odd one hot encoding, then the drop features we have, right? So right. So for one hot encoding, it will be the categorical feature, and this is how our transformer looks like, right? And now we can apply simply fit and transform on our X data, and after that we can see. So here we are seeing all the columns, and here we can see our transformed data. Now we can see the class attendance is our 310321. So this has become our class attendance. Remember here we have not passed, like over here we have not defined, so here we have defined this ordinal encoder as an integers, so here we have defined the data type as an integers, right? So but we can see the other features, all the other features looks like all the other features in this column as an float data type. So it has automatically converted as a float data types, right? And that's the reason we are seeing the data as a float, right? Now, how do we deal with the unknown category, right? So when we create a pipeline with a column transformer and pass it to the cross-validate functions, let's do that. Here we are using our column transformer passing to the and the SVC model. When we pass this pipeline to the cross-validate, what we see is, here you can see this output as a warning. We can see that found unknown category biology in column 0 during cross-validation. What is meaning? Meaning is when we check the categories, all the categories count of the categorical column, right? when we see that, here we can see that biology has only one instance in the entire columns. So when we do like when we do use cross validate, right, so there is a node, because we know that this, for this biology, there will be a one new columns where it will have all the zero, but at one time, right, but at one row it will be one, right. So where the values will be one, right, there will get the issue, right, because there is no mixed value into the validation data set, and that's the reason. So let's say that if the biology as a one goes to the goes to the training data set, right, but in the validation data set there is all the zero, so there we'll get the issue, right. For that reason we are getting this found unknown category biology in column 0, right. So how do we deal with that? To deal with that, we can simply pass handle unknown equal to ignore argument, and that's it. It will create rows with all the zeros, right. And here we can see that. So here, now in the now in the categorical transformation, here we're saying handle unknown as an ignore, and that's it. After you do that, let's create a pipeline and let's do the cross validate, and now we have no issue over here, right. So this is one way to solve. uh, Basically this is a very rare chance that you might get, but if you get this kind of situation, you know how to deal with that, right. So with this approach, all the unknown category will be represented with all zeros, right, and the cross validation is running okay now, right. Right. Now, categorical features with only two possible categories. Sometimes we have the feature with only two possible category, right? Now, if you want to apply one-hot encoder on such columns, right, it will create a two column. But again, we can, like over here, we can see that when like this enjoy courses had only two category, yes or no, right? If there is an yes, right? So if there is an yes, right? So it will be one, otherwise it will be zero, right? So even though if I can create like, even though if I look the one column, let's say that if I look the column for yes, right, so there will be one where the value will be yes, and there will be zero where the value will be no. So what I'm trying to explain over here is we can capture both yes and no scenario with one column only, right. So to deal with that, basically we do not want a two column to kind of handle this yes, like we do not want one column for yes and we do not want one column for no, right. And for that we can use like for that we can use drop equal to if binary. So when we do the one hot encoding, we can simply pass drop if binary. That means if there is only two category, one will be dropped, right. And yeah, after that, when we apply fit and transform, here we can see that, like here we can see this is our original data, and after the encoding, here we are getting the values in 1010, right. So one, if there is an yes, it will be one. If there is no, this means that it's a no, right. So if there is a zero, this means that it's a no. So now again, let's create the all type of categorical column. Here we have the numerical feature, we have the categorical feature, ordinal feature, binary features. Now we have the binary feature now, which is the enjoy courses. We have the pass through features. Now for the drop feature, there's no columns, right? So now here in the column transformer, here we are saying like here we're saying for the ordinal encoding, we are saying this one not encoding, but we have to say if binary, then like drop if there is a binary category, right, and that's it, right, all the transformation it will happen, right. So this is our column transformer, right, and after that we can pass with the pipeline, we can do the cross validate function, and this is the output that we are getting, right. So we are getting training score as 94, between 94 to 100%, and then test score sometimes we have got the 100%, sometimes we have got the 50%, right. Now we'll do the column transformer on the California housing data set. Now, here we are loading our data set. After that, we are splitting our data into training and testing. Here we can see our California housing data sets, right? Here our Y value is the median house value. So first, we are again creating some new columns like the room per household, bedroom per household, and the population for per household for both training and the testing data. And then after that, we are just trying to check the first few examples of the data, right? Now here we are dropping some columns which is not necessary, right? For from both training and testing, and then we are importing our make column transformer, right? So here the first 10 examples of our data we have, right? So this is our X data we have, like this is our X train data we have, right? So we have this room per household, bedroom per household, and population per household, and then Y value has the median per household, right? So our Y value is like median house value, right? These are the columns of the training data. Now first we have separated the numeric feature, categorical feature, and the targets. So we can explore some like we can explore our data with the info function. We can check whether do we have not like a nan value or not. Here we can see that we have the missing value in the bedroom per household. We can check the volume counts of the ocean proximity. So here we have this. So the island has been repeated 5 times, and all others features like all of the category is right. So this is our categorical columns. Now for the numeric column, we have to make a numeric transformer, right? So here we are creating a pipeline. The pipeline first we are doing the simple imputer, then the standard scalar, and then for categorical column we are applying the 100 codings. Now now we are applying numeric transformer, that means this transformer to the numeric feature, and then the categorical transformer, that is 100 encoder, this transformer to the categorical features. This becomes our preprocessor object, which is a transformer object. Now here we are applying fit and transform on the training data, right? Now after that we know that this that 100 encoding will change the number of columns, right? So we are extracting which columns it is there with the, so here we are extracting the feature names for the categorical of columns, right? This is our numerical column. So like here we are adding our numerical feature plus all the categorical features, and so our total columns are this, right? And now we are trying to look at our pre-processed data, right? Here we can see that we are looking at our pre-processed data, right, in the form of data frame. So this is our data we have, right? And now first we are trying our dummy regressor. So we can see that we are getting the 0 output for the both training and the test score. As a dummy regressor, this means that we have got the 50% accuracy. Now we are trying our SVR, which is the support vector algorithm for the regressions. Now for that, here we are making a pipeline with the preprocessor and the k-neighbor regressor. We can check our preprocessor like our pipeline object, right? Now we are trying to check how the KNN pipeline looks like what are the score do we get for the KNN pipelines. So for the KNN pipeline, we can see that our test score is 70% and our train score is 80%, right? And now we are now currently like over here. So like after that, we have used the KNN pipeline, right? Here we have built our, so now here we have built our KNN pipeline, but after that, here we are building our support vector regressor pipeline, right? Or the SVM pipeline. And the SVM, we are achieving a very bad result, right? So for SVM, our training and test score both are very much looks like a random regressor, right? So we're not getting a good accuracy, right? Maybe we have to tune the hyperparameter. So we are testing our model with the C as an 10,000 value, which is a different type of parameter that we are choosing for the C value. And after that, we can see that we have got the better score, that is 70% and the 71%, right? Now with the bigger C, so that means that with the bigger C value of the C, the results are much better, right? Now, what will happen if we have to do 100 encoding with the many categories, right? So the question is, do we enough like how do we handle like categorical data we have if we have so many categories, right? So basically the question is, do we really want to use certain feature for the predictions, right? So again, consider that if you have some features that is like let's say that like if we have a column with the with the many categories, but most of the categories are only just a few categories, right? So we have only like let's say that that the like we have only the three category, which is the prime category into the data set, but the every other categories are just repeating 3 and 5 times into the data set. So the question comes as like, do we want to use that features, right? If we can like in the real world, what do we do is basically we combine the like we combine those features or like those category who is kind of repeating kind of a very few times, or basically we replace them with the other names, right? Now the question comes, do we need to pre-process the target? Generally we no need to do this when we doing like when we do the classification, right? So when we do the classification, we do not need to transform any like we do not need to apply any pre-processing to the target data. But in regression, it makes sense. We'll learn about that, like we'll learn about in what cases, like what happens if we pre-process our y value, right? Especially if you have the regression data. Now let's talk about how do we encode our text data, right? Now, consider that this is our toy data set we have, right? So this is our toy data set we have. So basically, here we have this the SMS, and then the target is spam and not spam, right? So like here we have this low, you are always so convincing. Basically, this message does not look like a spam, but this message which talks about the money looks like a spam, right? So we have just created the toy data set, right? Now what happens, like how do we deal with that? So what happens if we apply one hot encoding uh, to this text data, right? So basically here we are considering this text data as a category. So what will happen if you apply it? So basically it will create one column for every category, right? So it has created a kind of one column as a category. So every column, like every text data, this every sentence will be considered as a category over here, which is not a good choice, right? So this is not what we want, right? So here we do not have fixed number of category, right? So each category is likely to occur only once in the training data, right? And we won't learn anything meaningful if we apply the one-hot encoding or any ordinal encoding in this type of features. So how do we pre-process, like how do we process or encode our text data, right, into a fixed number of features so that we can learn some patterns? So basically, this is a field of like we can we have the various techniques to deal with our text data, and this like we learn this in the NLP domain, right? So NLP is a field where we learn how do we process or what is the best way to represent text data as an as a fixed vector, right? So here we have some popular tools to kind of convert our raw text data as an vector. So one of the tool are like bag of word, TF-IDF, and then we have the embedding representation. Here we'll discuss about the bag of word, which is the very popular techniques which the people used earlier, right? So like here, now this technique ignores syntax and the word order, right? If you are representing any any sentences or any text data into the bag of word representation, right, it removes the word order, right? It has the two component. One is the vocabulary, which has all the unique words, and the other one is the value indicating either a presence or absence or the count of each word in a document, right? So consider that here we have this entire sentences, right? So in the bag of word, these like these word order does not matter, right? So what do we do? We kind of get like create a dictionary for this, right? And after that, here we are considering that, right? So how many times this each value, each word has been repeating, right? So we are considering this, right? So for these sentences, right, so now we'll have these word order, right? So again, we can achieve this using like we can achieve the bag of word using count vectorizer, right? So we convert a collection of text document to a matrix of word count, right? So here we convert a collection of our text document as an word counter matrix, right? Where each row represents a document, right? And each column represents a word in the vocabulary, right? Again, each row represents a document and each columns represent a word in the vocabulary in the training data, and each cell will represent how often the word ordered, like how often this word occurred in the document. Like, how do we do that? So here we'll import our counter vectorizer. We are creating our models with the counter vectorizer. Remember, this is our like this counter vectorizer is our transformer. And after we do that, right here we are trying to see the output. How does this counter vectorizer, or what this counter vectorizer does to our text data, right? So here we have this entire sentences, right? We have that unique word for the sentences, right? Now, if this specific word is present in this sentences, it will be 0, otherwise it will be 1, right? So now we have the vectors, right? And and again, so the way we get the result, basically we get the sparse matrix. Like we do not get as an ND array, right? So basically our this count vector or scikit-learn, right, store this information as a sparse matrix because we have a lots of zero value present in our matrix, right? And here we can see that when we check the x count, we can see it's a compressed sparse matrix, right? So why sparse matrix? Because most of the words are not present in the given document, so resulting there will be a lot of zeros, right? And if you do so, we'll get a computational savings a lot, right? And yeah, and there is a bit of overhead because we also need to store the location, right? If you store the matrix in the sparse matrix or a compressed sparse matrix, right, we have to store the location, like over here, like the location at 3rd and 27 is 1, right? So we can see the location, and here we are just trying to print the total number of elements are present in the matrix. So the total number of non-zero element is 71. Again, the 90% of the element is non-zero, rest all the elements are zero, right? Now now this one-hot encoding and sparse matrix. So by default, one-hot encoder also creates sparse features, right? But you could set sparse as false to get the regular NumPy array, right? If there is a huge number of categories, it may be beneficial to keep them as a sparse. So for smaller number of category, it doesn't matter, right? So there are some important hyperparameter we have for the count vectorizer, like the binary. So when we say the binary is true, that means basically it will check if the values are present, it will be 1, otherwise it will be 0. Basically, it will not count how many values are present. When we say max features, so it's like only consider the top max feature ordered by the frequency in the corpus, right? It will not consider all the features, which is like, let's say that if we have one of the word which has just kind of appeared only once in an entire document, right? So we do not want to kind of use that unique words, right? We have the max def, which basically this means this will be used to ignore the feature which occurs more in the max def, like max df document. Same as we have the min df, then again we have this n-gram range, which consider the word sequence in a given range, right? So we have these hyperparameters for that. Here we are just trying to check our, like here we have this, like here we are creating our count vectorizer with the default parameter. So with the default parameter, we'll get this, right? And when we set the binary as true, so here we are getting, we can see that like this, like I think this update word in this sentence has been repeating 2 times, so we are getting 2 over here. But when we say binary as true, it will check if the particular word is there or not. It will not check how many count, like it will not count the element, it will just check the value. And here we can see that now now, even though the update has been repeated 2 times, we have got 1, because when we set the binary as true, it will check whether this particular value is true or not. So the output will be in the form of binary only, right? When we say max feature as 8, it will only consider the maximum 8 feature, not all the feature. Like here we have considered all the feature, but here we are considering only 8 features, right? And after that, here we are kind of trying to count those features, like how many count do we have for these features. So here we can check the count, right? But what if we say the binary has 2 and the max feature has 8, right? We have got the output, right? So here will, like, if the particular element, let's say that if any of the element has been repeating 2 times, right? So again, so for that it will be 1, right? So it will be, so the max feature will be there based on the binary features, right? And that's the reason we have got the output over here, right? Now here we have created a pipeline, our counter vectorize and the SVC. We are applying fit method, right? And after that we are applying predict method. Now we can see this is the output we have got, right? Now the question is this a realistic representation of text data? So basically it's not the best representation of text data, but this was the first representation of text data where people used to do that, and it is not outperforming algorithms, right? So we do not generally use this kind of algorithm in the real setup. This is just for the educational purpose, right? Now, what did we learn today? Basically, we learn about the column transformer, right? We learn about the ordinal feature, like we learn about the different type of transformation on the different type of features. We also learn how to deal with the text feature like the back of word algorithms, right? And yeah, that's it. That's it for this class. Thank you very much.